All right, let's jump right in. We're about to pull back the curtain on the hidden materials that make, well, pretty much everything in our modern lives possible. From the very first thing you use in the morning to the power that keeps the lights on, it's a world built on stuff we rarely even think about.
It sounds like the beginning of a really weird joke, doesn't it? A tube of paste, a super complex piece of tech in your pocket, and this massive piece of transportation. I mean, they seem like they're from different planets, but believe it or not, they are all connected by the very same building blocks.
And the answer to that little riddle? You guessed it. It's minerals. These incredible substances, pulled from the earth, are the invisible ingredients in nearly everything we touch and use, every single day.
Okay, check this out. Let's just take your toothpaste. That fresh, clean feeling you get? You can thank gritty minerals like silica and limestone for that. And the cavity protection? That comes from fluoride, which we get from a mineral called fluorite. Even the bright white color and that little sparkle comes from titanium oxide and mica. It's literally a mineral cocktail before you've even had your morning coffee.
And of course, it goes way beyond toothpaste. I mean, just look around you for a second. The roads, the railway lines, the buildings, the very screen you're watching this on right now, all of it, every last bit, is manufactured from minerals and powered by energy that comes from the earth.
So what exactly is a mineral, geologically speaking? Well, it's a substance that occurs naturally and has a specific, repeating internal structure. And that structure is everything. It's what gives each mineral its unique properties, why talc is so soft you can make powder from it, and why a diamond is the hardest thing we know.
Which brings us to the next big question. If these things are in everything, where on earth do we get them? How does a rock buried deep in the ground become a tiny component inside your phone?
You see, minerals almost never appear in their pure form. They're usually mixed in with a bunch of other elements in something we call an ore. And here's the crucial part. For anyone to even bother mining it, the concentration of that mineral has to be high enough to make the whole expensive process actually profitable.
And this is where it gets really cool, because each one has an epic origin story. Some minerals, like copper and zinc, were literally forged in fire, molten rock forced into the cracks of other rocks. Others, like coal, were formed from ancient life, settling in layers over millions of years. Bauxite, where we get our aluminum, is basically just what's left behind after rocks on the surface decompose. And then you've got the really precious stuff, like gold, that gets washed down by rivers and settles in valley floors.
But getting these geological treasures out of the ground is not a simple or clean process, not by a long shot. It comes with a pretty heavy cost, both to the people doing the work and to the planet itself.
To give you a sense of the sheer scale we're talking about, just look at bauxite production in India. In 1 year, a single state, Odisha, accounted for a whopping 65% of the country's entire output. Imagine the amount of earth that has to be moved to get at these minerals. It's just staggering.
And behind those huge numbers are real people. Mining is an incredibly dangerous job. The risks are constant, from the mine itself collapsing to fires and flooding. It's a harsh reality that miners face every single day.
The impact also ripples out far beyond the mine. The dust and fumes can cause serious lung diseases for people nearby. The process can contaminate entire water supplies, and all the waste that's dumped degrades the land and pollutes rivers. It's this whole cascade of environmental problems. And this all leads us to a fundamental and frankly kind of scary challenge. The minerals that fuel our entire society, they're not unlimited. We are rapidly consuming resources that took the planet millions and millions of years to create.
Now, I want you to let this number really sink in for a second. All the mineral deposits that we can actually get to and use make up just 1% of the Earth's crust. 1%. That is an unbelievably tiny fraction to support the entire global economy.
But here's a fascinating story that kind of flips the whole idea of scarcity on its head. Back in the 1800s, aluminum was so hard to get that it was way more valuable than gold. Emperor Napoleon III used to serve his most important guests with aluminum forks and spoons, while the, less important people had to make do with gold. Today, of course, we wrap our leftovers in it. It's just a powerful reminder that technology can change everything.
So the crucial point here is that we do have a path forward. We have to get serious about conserving these resources. That means improving our technology for sure, but maybe more importantly, it means being way smarter with what we've already pulled out of the ground. Recycling metals, using scrap, these aren't just nice ideas, they're absolutely essential.
And this shift is nowhere more important than in how we generate our energy. But here's the twist.
The future of energy is just as dependent on minerals as our present is. The real question is, which minerals?
We're basically standing at a crossroads. We have the conventional path, which relies on finite fossil fuels like coal and oil. We all know they cause serious environmental damage. Then there's the other path, renewable sources. This is the sustainable route. But here's the thing. Moving to renewables isn't about leaving minerals behind. It's about trading one set of minerals, like coal, for another, like the lithium, cobalt, and rare earth elements that are absolutely vital for batteries and turbines.
And this isn't science fiction. It's happening right now. But let's look closer. Those solar panels, they rely on silicon. The batteries you need to store that solar power, they need lithium. And those gigantic wind turbines, they require tons of steel, zinc, and super powerful magnets made from rare earth elements. The green energy revolution is, at its heart, a mineral revolution.
And ultimately, all of this brings us back to one simple but incredibly profound idea. Whether we're burning coal or building wind farms, there's always a material cost. And that's why every single bit of energy we save is energy we don't have to generate in the first place. It's the cleanest, most efficient source we could ever have.
So, I'll leave you with this little challenge. Just for a second, look around you. Your desk, your chair, the window, the light bulb over your head. How many things in your world can you trace back to a rock, forged in fire or settled in layers millions of years ago? Turns out, the hidden world of minerals isn't so hidden after all. It is, quite literally, everywhere.